Okay guys, welcome back to this page. Okay, now continuation for centroids. Now, the shapes we've done before can be oriented in a different manner. How? Now this is also a triangle, but now is a right angle triangle. Okay, so this part is at 90 degrees at the axis. Okay, while this part is at 90 degrees, but not at the axis given. The tip is now at the axis. So how do we find the centroid when it's done this way or this way for a triangle? Now, same pattern. Remember, the centroid is the center of the object. Okay, so if I pick this point as the center of the object, for example, we'll call this the word now the centroid. Okay, call this the centroid. Now, the distance from the centroid to the x-axis, remember, is the y-centroid, while from that same centroid to the y is the x-centroid. Now, looking at the diagram, the orientation, okay, the x-centroid is gonna be equal to, okay, the base divided by 3, because we have 3 partitions. If you do that, 1 2 3, okay, so the base over 3, while the y-centroid will also be equal to the height over 3, okay, because you can also have 3 partitions for that guy. Now this is for this case of a triangle. Now how about the tip of the triangle is now at the middle of the axis? How then do we find the center? Again, somewhere around here should be the center of the shape. Okay, so therefore from here to here is the y-centroid, while here down to this part is the x-centroid. Now looking at the diagram, this x-centroid and this x-centroid, the second one will be more than this first one because from the orientation is obviously more. Now if we know from the centroid to the edge of the triangle as b over 3, okay, so what will not be the remaining one from that same edge to the tip? Remember, in fractions, if you have 1 over 3, okay, and have a total of 1, for example, how do you get the other part of the fraction? I'll just do 1 minus 1 over 3. That should give you 2 over 3. So therefore, it means that in this kind of diagram, the x-centroid should now be 2 times the base over 3, okay, because if you add this and this, you're going to get just the base, the full base, okay, and then the y-centroid remains the height over 3. So this is for this case for triangle. Now for a semicircle, the base of the semicircle is now at the y-axis. So again, how do we find the centroid? So from here up to here becomes the x-centroid, while from here down to here becomes the y-centroid. Okay, so how do we get that in this diagram? Now looking at the diagram already, we're going to agree that the x-centroid is just at the part, okay, from the center to not the edge but to the y-axis. So this should not be the radius and it should not be the half of the radius. So we're going to say the x-centroid is going to be 4r over 3 pi again, like we did before. Okay, why for the y-centroid it is from the center to the circumference. So the y-centroid remains the what now? The radius of the circle, of the semicircle rather. Now for the quadrant, that's 1/4 of a circle. How then do we find the centroid? Pick here as my center. You have your y-centroid and you have your what? Your x-centroid. Now let's not waste time. The x-centroid here is just 4r over 3 pi and same as the y-centroid, 4r over 3 pi. Okay, so these are the centroids, okay, for semicircle and the quadrants of a circle, and then we've done for the triangles. Okay, so these formulas, you need to make them familiar with yourself. Okay, get used to them because we're going to be applying them in questions that deal with finding centroid or moments of a shape. Thank you and God bless you. Just for clarity's sake, how about when the axis is passing through the center of the shape? How then do you get a centroid? Don't forget, centroid is the distance from the center of the shape to the axis. Now in this case, if the axis is now at the center of the shape, what then should be the x and the y centroid? For this full circle, it is safe to say that there will be no distance from the centroid to the axis because the centroid is at the axis. So in this kind of shape, the x-centroid will be 0 and the y-centroid also 0 for this shape. Now for this shape, since it is at the middle of this base, okay, now we remember that to get the y-centroid, the y-centroid is the distance from the center of the shape to the what now? To the x. Now, if the shape is oriented this way, we say the center should be somewhere around here. Don't forget, somewhere around here. So we can also find the y-centroid, but we cannot find the x-centroid because the x will be from the center to the y-axis, and the y-axis is at the center. You can see that, right? So the y-centroid is what we know as 4r over 3 pi, okay? But the x-centroid in this case is now 0 because there's no distance from the center to the y-axis, but there's distance from the center to the x. Don't forget that. So that's 4 over 3 pi, and for x is 0. Okay, now for this again, this is the center of the shape, and that is where the axis starts from. So again, the x-centroid is 0 and the y is also 0. Now for this shape, okay, now the axis is now at the base of the semicircle. Remember, this can be the center of the shape. Okay, so the distance from the center to the y can be known. That's the x-centroid, but we cannot find the y because it's the axis of the x is at the middle. So again, for this shape now, the x-centroid is 4r over 3 pi, while the y-centroid is just 0. So it is very easy to, you can manipulate the kind of diagram given to you, okay? If it is passing through the middle, then you try to observe the shape and see if it's a distance from the center to the x-plane or from the center to the y-plane. If there's no distance, therefore, it becomes 0, okay? So this will also help you in solving questions under centroid. Our next video, we're going to look at how to get a moment of inertia for all the shapes at their centroids. Thank you very much.